All right. So to write expressions for the length and width of a rectangle with area expressed by a polynomial. Okay, so we have a rectangle, right? This is the length, this is the width, and we're talking about the area. So we know the area equals length times width, right? That's the area of a rectangle. It's all this bit inside of it, okay? So it says to write expressions for the length and the width of a rectangle with area expressed by a polynomial, you need to write the polynomial as a product, right? Length times width, that's a product. You can write a polynomial as a product by factoring it. Okay, so let's look and see what they're talking about here. It says, example 2, it's an application. So it says the area of a court for the game squash is 9x squared plus 6x square meters. Factor this polynomial to find the possible expressions for the dimensions of the squash court. So it says it's the area of a court for the game. Okay, so squash is played on a rectangle, and it wants to know the dimensions. So that means it needs to know the length times the width. So we need area equals length times width. We need two things multiplied by each other, and then that will tell us what the dimensions are, right? So here we don't have that. We don't have two things that are multiplied. We have two things that are added together. So what we have to do is we have to factor this in order to get two things that are multiplied by each other, okay? So we can find the dimensions, right? The length and the width. That's what dimensions are. When it says dimensions, that means what's the length, what's the width, okay? So, all right, so we're gonna factor this. So what's common? So we have 9x squared plus 6x. So there's numbers and there's letters. So what's the biggest number that goes into both 9 and 6? I'm gonna say it's 3, right? 3 goes into 9, 3 goes into 6. And then the variable, we got an x squared and we have an x. What's the most amount of x's that go into x squared and x? Or they both have in common, right? And I think that would be x, right? There's an x here and there's an x within x squared. So it's gonna be 3x. That's what we're gonna factor out. And then we're gonna go 3 times what is 9? 3 times 3, and x times what is x squared? It would be x times x, right? And we go 3 times 3, we get 9. X times x is x squared. Perfect, okay? Then this is a positive. We need a positive here. And then we're gonna go 3 times what is 6. 3 times 2, right? 3 times 2 is 6. And x times what is x? Well, x times 1 is gonna be x. So that's it, okay? So this is our factored form. We could check it, right? Let's go ahead and check it just to make sure. Okay, so we're gonna go here. 3 times 3 is 9, x times x is x squared, and then we go here. Ooh. 3 times 2 is a positive 6x, and that is the same thing. So we know that we factored it correctly, and this is our area, right? So our dimensions, this is our length and this is our width, or really either way. So we're gonna say length equals 3x, and width equals 3x plus 2. Those are our dimensions. All right? Perfect. Okay, now it is your turn to check it out with example 2. Okay, where's my friend? Here's my friend, the pause dragon. I might need to pause your device. Go ahead and work out this, check it out, example 2. When you get done, press play and we'll talk about it. All right, see you in a bit. Okay, this says, let's see how you did. What if the area of a solar panel on another calculator is 2x squared plus 4x centimeters squared? Factor this polynomial to find possible expressions for the dimensions of the solar panel. So the solar panels are rectangles, right? So we can call this our length and this is our width, okay? And the area of this is equal to length times width, right? It's a product of the dimensions. So we are going to have to factor this. Right now they're added together, so we have to factor it in so that we have two things that are multiplied by each other. So let's look here, look at the numbers, and we have letters, right? So what numbers what's the greatest common factor of 2 and 4, right? What number goes into 2? What's the biggest number that goes into 2, which also goes into 4? And I'm gonna say that that is 2, right? And now let's look at the variables. What's the biggest amount of variables that go into both x squared and x? And it's gonna be x. And then I'm just gonna go, okay, 2 times what is 2? Well, it's gonna be 1, right? And then x times what is x squared? It's going to be x. And then we move here. This is going to be positive. 2 times what is 4? And 2 times 2 is 4. And then x times what is x? And it's going to be x times 1, but we don't need to write it, right? X times 1 is x. We don't need to write that. So this is our area, right? Which means our dimensions are here. Here's my length is 2x, and my width is x plus 2. But I want to check this, okay? So I'm going to check it. I'm going to write this 2x, x plus 2. Okay, so we're going to do that distributive property. 2x times x is 2x squared, and then 2x times 2. 2 times 2 is 4, and then there's an x, and so we want to see if this is the same. 2x squared plus 4, and it is, so that's perfect. So if you got this one right, yoku denkimashita, you did a wonderful job, and I'll see you in a little bit for example 3.